Okay, so we're going to continue with our angle of elevation, angle of depression, finding angles inside of a triangles, as well as sides of a triangle practice. We're about to mix it all in there, okay? So we're going to go ahead and work a couple of examples, couple word problem examples, and figure out, based on the information that we've been given, what we need to use in order to find what we've been asked to find. So let's hop right into it. In triangle DEF, DE is equal to the square root of 3 and DF is equal to 2. If the right side is at D, what is the measure of angle F? Draw and label a diagram, then calculate the measure of angle F. So I am going to draw my right triangle. Okay. Now, it says that the right angle is at D, so I'm going to put the D right there. Okay. So then I'll make this E and this F. Okay. And it says DE, this side right here, is equal to the square root of 3. And DF, this side right here, is equal to 2. If the right triangle is at D, what is the measure of angle F? All right, so we are looking for this angle. So I've got my right triangle, I've got it drawn. It's very important that you read the entire problem, because if you would have gone, or if I would have done like I normally do, DEF, well, the angle D would have been in the wrong place. So it's always good to read the problem all the way through before labeling and creating our triangle. So I got my right triangle. I'm being asked to find an angle. So let's determine what's my opposite and adjacent sides. So here's the angle I'm working with. I draw my arrow to the opposite side. So this is my opposite side. That makes DF my adjacent side. And the hypotenuse is always opposite the right angle box. So I'm being asked to find an angle when all I've been given is the opposite and adjacent side. So what trig ratio requires the use of opposite and adjacent sides? Well, that would be tangent, right? And remember, we're not looking for a side, so we're not just going to use the tan, regular tan. We're going to use tan inverse. So I set my problem up as follows. X is equal to, we're using tan inverse because we're looking for an angle. The tan inverse, and I'll go ahead and write the equation out, the opposite side over the adjacent side. Okay? So X is equal to the tan inverse of the opposite side, which is square root of 3, and the adjacent side, which is 2. Okay, so if you know anything about special right triangles, you might already know what the answer of this is. Okay. Oh wait, no, not this one, not with tan inverse. Disregard that, I got a little ahead of myself. But regardless, so grab my calculator, hit second. Here, I'm clear it out so there's not a whole bunch of extra stuff. I'm gonna hit second, then tan inverse of, now to find the square root button, you hit second, and then this little radical sign right here, you're going to hit that. So second square root of 3, I'm going to close the parentheses once, that divided by 2, and then close the parentheses. Okay, I'm going to leave that up here just so you all can kind of see what it looks like in the calculator, because it's very important that you put it in the way it appears on the paper in the calculator, otherwise you get a bunch of craziness as your answer. Hit enter, and there you go. So X is equal to 40.89 degrees. Okay. So there's our first one. Okay. Our next example will be as follows. From the top of a 120-foot tower, an Air Force controller observes an airplane on the runway at an angle of depression at 19 degrees. how far from the base of the tower is the airplane? So, like always, draw myself my picture. So, I've got a 120-foot high tower. Okay, a tower like this, like that. All right. Regardless, that tower is 120 feet. Okay. Now, the air traffic controller right here notices that the airplane is on a runway at an angle of depression of 19 degrees. So if you remember anything about the angle of depression, I'll draw my airplane right here. Okay. Okay, not a bad looking airplane, that right there. But he notices that there is an angle of depression of 19 degrees. He notices that the airplane is right there. Okay. So this is the height of my tower right here. And here's my right triangle. Okay. So remember, the angle of depression is on the outside of the triangle. So technically this right here is my angle of depression, this angle right here. But remember, I've got parallel lines cut with a transversal, so I've got alternate interior angles. Okay. So this angle and this angle right here are the same. Okay. Because remember, our angle of depression is equal to our angle of elevation. Okay. So I've got this angle here being 19 degrees and the height of the tower being 120 feet. And the question asks me, how far from the base of the tower is the airplane? So here's the base of the tower. Here's the airplane, even though I drew it a little further. But I need to know what X is. Okay, so let's start labeling our sides. This is my opposite side. So that means this is my adjacent side. And this is my hypotenuse out here. So, given, well, first of all, am I looking for a side or am I looking for an angle? I'm looking for a side. So since I'm just looking for one of the sides, I can use regular trig ratios. So, what trig ratio? I've been given the opposite side, and I need to find the adjacent side. What trig ratio deals with opposite and adjacent? Tangent. So, I can say the tan of 19 degrees is equal to opposite, which is 120, over adjacent, which is x. Set this up to cross multiply. Okay. So x times the tangent of 20 times the tangent of 19 is equal to 120 times 1. Well, that's just 120. Divide both sides by the tangent of 19. Okay. These cancel out, and x is equal to, well, let's go ahead and break out the trusty calculator, 120 divided by the tangent of 19. And that is 348.5 feet. So, another example on how to use trig ratios, and understanding that when you're looking for an angle, you use the inverse operations, and when you're looking for a side, you use regular sine, cosine, and tangent.